Okay, welcome back to what everyone came here to see. So, my Python for DevOps series, if we look at the popular, one, two, three, my most popular series by far. Each of these has more than 1,000 views. So, and this one actually pulled ahead recently over my introduction one that was featured on my homepage for a long time. So, yeah, I'm going to continue that one by popular demand. So where I left off last, I was reading the book. I was on chapter 14, so we're getting into the good stuff, the machine learning and machine DevOps. So like a new field in IT arose where there was a large separation between kind of network engineers and developers, and they kind of merged together and started doing things in a similar way. These tools like Ansible, you know, actual like proprietary solutions by large companies like Cisco. Cisco DNA Center, I think is probably part of why there is now the term DevOps. So they merged together and they brought software development principles and practices to operations, things like managing servers and the operations of an IT department or of a business. So that's where this new word comes from. As far as I know, I could probably double check on ChatGPT. So explain the evolution that brought the term DevOps. So explain the evolution that created. Because that's just on the top of my head. My desire on this channel isn't just to give misinformation. So yeah, I'm going to use a different disinformation machine instead and have that give you disinformation instead of me.
The term DevOps represents an evolution in the IT and software development industries, focusing on breaking down silos between development, dev, and operations ops teams to enhance collaboration and productivity. This evolution has its roots in several key movements and technological advancements. Let's explore the journey that led to the creation and widespread adoption of the DevOps concept. Agile Software Development Foundation. The DevOps movement is deeply rooted in Agile and lean practices. Agile software development, emerging in the early 2000s, emphasized flexibility, customer collaboration, and the importance of delivering functional software in short cycles. Agile methodologies encourage collaboration and adaptation, but often focus more on the development side of software creation. The need for faster delivery, rapid technological changes. As technology advanced rapidly, businesses face increasing pressure to deliver software faster and more efficiently. The traditional waterfall model of software development and the separation between development teams who write the software and operations teams who deploy and manage the software led to bottlenecks, slow delivery times, and inefficiencies. The rise of automation and continuous integration, continuous deployment, CI/CD, automation tools, the development of automation tools for building, testing, and deploying software help bridge the gap between development and operations. Continuous integration, C, and continuous deployment, CD, practices allowed for the automatic testing and deployment of code, leading to faster development cycles and reduced potential for errors. The first use of DevOps term coined. The term DevOps was first coined by Patrick Dubois in 2009. It emerged from the first DevOps Days conference in Belgium, organized by Dubois, which brought together professionals from the development and operations spheres to share ideas and best practices. Culture shift, collaboration, and sharing. DevOps is not just about tools and processes; it's fundamentally about culture. It emphasizes collaboration, shared responsibility, and breaking down silos between teams. This cultural shift encourages open communication, shared problem solving, and a focus on the entire service lifecycle from design through the development process to production support. The cloud and infrastructure as code (IAC) technological enablers. The rise of cloud computing and technologies such as infrastructure as code (IAC) have significantly contributed to the DevOps movement. These technologies enable more efficient management of resources, automation of environments, and scalability, supporting the rapid deployment and iteration of applications. Continuous learning and adaptation evolution. DevOps continues to evolve, incorporating new practices such as DevSecOps, which integrates security practices into the DevOps process. The emphasis is on continuous improvement, learning, and adaptation to new technologies and methodologies. In summary, the evolution that created DevOps is a response to the need for faster, more efficient software development and delivery. It represents a paradigm shift in how development and operations teams collaborate, leveraging agile principles, automation, cultural change, and technological advancements to improve the speed, quality, and reliability of software.
All right, so pretty happy with that. Yeah, it has a lot to do with the rise with the agile movement, with CI/CD, and one thing I really like is it named names. What I like to do is whenever I learn of a big figure, so let's read this again. So this is the guy who came up with this term, DevOps. So this is a pretty important figure in IT. So what am I going to do? I'm going to click on him on LinkedIn, and I'm going to click the follow button. And I urge anyone who Oh, they want me to do this extra thing. Um, I urge anyone who's learning about IT or anything, if you find a really important figure, and in fact, I talked about, I forget what his name was, Donald or something. Um, his name was something Metcalf. Oh, Robert Metcalf. So, no, that's not the same one. Okay, so Robert Metcalf probably doesn't have LinkedIn, which that kind of makes sense. I don't think he needs one. Oh, you know what? I was spelling his name incorrectly. No, he has one. LinkedIn. That's what I like about LinkedIn. It's a when it comes to your professional image, I think it's a really good like tool in the toolbox. And the thing I really like about it is it puts you on rails. You know, if you're on Facebook, if you're on Instagram, you can very easily go off the rails, and because one of the important things for getting hired, as I mentioned in my other series, is fit. So you kind of get a chance to that I think you can be misjudged as a wrong fit if you're being a bit off the rails online. So that's what I like to do. Any really big name, I follow them, because then in my feed I get really good stuff coming in. So if I view my profile, that's not where I get my feed. If I click this button here, now I get my feed. So I get feed from people in the Agile Institute. I get feed based on my interests, and then so it's based on career goals, probably. So anyway, going back to the book. So I took a side step to try to get a Jupyter notebook running to go through these examples. One thing I want to do before starting is let's do that same thing in ChatGPT, but let's do that for ML ops. So we're going to use the same prompt, explain the evolution that created the term ML ops. And if that names any names, we're going to add those names to my LinkedIn. And I urge anyone watching to do the same. Connect and because that's what it is about, building a professional network. You want to know who these people are, even if you haven't met them. It's just kind of like in the government. You should probably know who the president is. That's if you ever fall and hit your head, you might be asked that. So I feel like that's similar in your professional career.
The term MLOps, which stands for Machine Learning Operations, represents an evolutionary convergence of machine learning, DevOps, and data engineering practices aimed at streamlining and improving the lifecycle of machine learning models. This evolution mirrors the broader shift towards automation, collaboration, and continuous improvement that spurred the DevOps movement, but with a focus on the unique challenges of machine learning. Let's explore the key stages in the evolution that led to the creation of the term MLOps. Rise of machine learning expansion. In the late 2000s and early 2010s, advancements in algorithms, computing power, and data availability led to a significant increase in the use and capabilities of machine learning, ML. Businesses and organizations began to recognize the potential of ML to provide insights, automate processes, and create new products and services. Integration with DevOps influence. As organizations sought to integrate machine learning into their products and services, they encountered unique challenges. Unlike traditional software, ML models depend heavily on data quality, model training, validation, and continuous monitoring for drift and data performance. The DevOps principles of collaboration, automation, continuous integration, and continuous deployment (CI/CD) offer a framework to address these challenges, leading to the initial integration of ML workflows with DevOps practices. The need for specialized practices, unique challenges. Machine learning introduces complexities not typically found in traditional software development, such as data versioning, model versioning, experiment tracking, and model serving. The realization that the DevOps framework needed to be adapted to accommodate these unique aspects of ML workflows led to the emergence of specialized practices. Emergence of MLOps coin term and definition. The term MLOps started gaining traction in the mid to late 2010s as a way to describe the specific practices, tools, and cultural philosophies that address the end-to-end lifecycle management of machine learning models. MLOps aims to automate the deployment, monitoring, management, and governance of ML models in production environments, ensuring they remain effective and accurate over time. MLOPs, tools and platforms, technology and tools. The growth of MLOPs coincided with the development of specialized tools and platforms designed to facilitate various aspects of the machine learning lifecycle, such as data preparation, model training, version control, deployment, and monitoring. These tools aim to reduce manual effort required to manage ML models and to bridge the gap between data scientists, engineers, and IT operations. Integration of data engineering collaboration. Successful MLOPs practices recognize the importance of data quality and availability. Collaboration with data engineering becomes crucial to ensure that data pipelines are robust, scalable, and reliable, providing the foundation for effective ML operations. Continuous evolution, adaptation, and growth. MLOPs continues to evolve, incorporating new methodologies and technologies as the field of machine learning advances. This includes embracing more sophisticated automation, exploring the integration of AI ethics and governance into the lifecycle, and adapting to emerging technologies such as generative AI and reinforcement learning. In summary, the term MLOPs evolved from the intersection of machine learning and DevOps, driven by the unique challenges of managing ML models in production environments. It represents an industry-wide recognition of the need for specialized practices, tools, and collaboration between various roles to streamline the lifecycle of machine learning models and ensure their ongoing efficacy and relevance.
All right, so that's that. I kind of didn't take away a lot from that. So it's time to move on. I'm gonna open my development environment. I wasn't listening. And open my VNV. And now do a notebook, so Jupyter notebook. And one really cool thing about Visual Studio is it shows the ports that are open. So I've got quite a few ports open. I actually, looks like I still have. No, it's not open, and we can see that with here. I actually do have these other ports open though. I'm not sure what these are. But they are part of this. So I might be able to reopen the port just from here. Nope, it looks like I need to put in the correct command, and I'm not sure what that is. Let's look in the history. Maybe it's still in there. So command number 80 should be pretty useful. So we don't have any running servers. So I'm not sure how to run the servers. Maybe it's command 75. Okay, yeah, so command 75 opens the Jupyter server, and then within the Jupyter server, there's nothing running yet, but all the files are saved. So from here is where you double click the file, select the kernel, and we can always start the preferred. I don't think this needs to be complicated unless you're doing something really complicated, but you'll be directed how to do that if you are. And then let's take a look at this untitled one. I'm not sure what this is all about. Oh, well, the untitled one is the one I've been using. So you know what? I'm going to leave this a tab. I'm going to delete this one because I'm not, it's not even filled out. And then I'll retitle the untitled one Chapter 14. All right, it sounds like I'm going to go bankrupt or something, but let's continue on. So hopefully that won't happen. So y.shape is the last part I put in. So let's see what we're at here. sklearn regression model. So where was that y.shape? Oh, here it is. So my bookmark's actually a little bit behind. So I'll move that forward. Unbookmark the last one. Oh, and I've got so this is location 8919. Now we got so instead of a location 89, we've got a one in location 83, which is older. So let's jump to the 83 one. Okay, that's just the chapter beginning, so I will delete the 8.3, and I'll use the newer one, which is listed in order here, which is 8.9. And now I'll take a break. I'll be back in a few minutes. All right, let's keep going on this. I've got a bit of time here this morning. but not unlimited. All right, so we did y dot shape. So next section is to split the data. The data is split into an 80%, 20% split. So I'll type in that next line. And actually, I don't even have to type it. I can, because this is the new client version, I can actually copy paste now. I couldn't before. And Jupyter notebooks make it really easy. You can just use the Control V to paste, just like you would for just about anything else. Now we can see there are multiple lines of code here, so we can put it all in a Jupyter cell. Sorry, I have a short cough. And the I wanted to create a new line, so I did Shift Enter out of habit, but that's not the way you create a new line. To create a new line, you just hit Enter. So now print is on a new line, and the second print is on a new line. So you can put things in the same cell, as far as I know. Okay, so it's saying that train test split is not defined. Yeah, and I don't see it defined, so I don't know. Oh, you know what? It's supposed to be imported. So you can see what happened. We didn't go back and run the all the cells again. So this was actually not loaded up. All we saw was kind of a cache, like seeing it what happened when it was ran before. So you can see we can put multiple lines in a cell. So I think that's how I'm going to do it for this cell, but I will restart the kernel and clear all output of the cells, and then run all the cells again. And that's maybe not the best way to do it, because if you have a lot of code to run, it's just going to take a lot of time. But for now, I'm okay with it. And there we go. We've got the same results in the book. I'm going to clear it out and run it again, because the kind of linting, the formatting of the code was not to my liking. So restart and clear. And then run. And I'll be back in a moment. All right, I'm back. All right, so there we go. We've got all of that looking good. The output should match what was there. Yep, so we've got 20,001 up there, and then 5,001. So next is to fit the model. Now, the model is fit using a linear regression algorithm imported via sklearn. So the first step, obviously, is to import that. And again, I can just copy and paste all of this, which is great. Remove the author's information and clean it up by putting things on new lines. All right, there we go. So now I can run this cell with Shift Enter. We don't have any output command such as print or anything like that. One thing I would like to call out is this seems to be procedural programming, and in fact our import statements in doing this are not all at the top. So this seems to kind of violate some of the conventions you would do if it was all one file, which is interesting. But moving on, print accuracy of linear regression model. Now the trained model can show what the accuracy is in predicting new data. This is performed by asking for the RMSE, or root mean squared, data of the predicted and test value. So this is a bit beyond me. I'm not sure what the RMSE is. The root mean squared, I mean, I can kind of know what that is. I mean, it's square root. Mean is like the average. But my knowledge of advanced statistics kind of doesn't extend that far beyond that. I would be interested in a conversation with ChatGPT. You know what? Let's do that. So I'm gonna clean all this up. So we've got this import statement. Now we've got another one with and then we've got a comment on the next line, separated by spaces here. And then on the so the comment says RMSE, I think. Oh, yep. So root, and then the next line, and we can see that here. RMS starts on the next line. There we go. And I'll clean this up. I don't know if it's meant to be like that. That's just the way they format it. But for me, I'd rather it be like that. And then the next thing I'm going to do on the last line is show that output. So let's do a control or a shift enter. And now let's not ignore the crazy times we're in, and let's get a basic kindergarten explanation of the root mean squared error. So give me a basic it's like a German word, kindergarten. Is there a T in there? I don't know. Kindergarten explanation of the root mean squared error. Wow.
Imagine you're trying to throw beanbags at a target on the route, and you want to know how close your throws are on average. Each time you throw a beanbag, it lands somewhere near the target. Sometimes it's really close, and sometimes it's a bit further away. Root mean squared error, RMSE, is like a special way of measuring how good you are at throwing those beanbags. Here's how we figure it out in a kid-friendly way. Measure the misses. For every throw, we measure how far the beanbag landed from the target. If you missed by a lot, the number is big. If you were super close, the number is small. Square the misses. We then take each of those misses and multiply them by themselves. This is called squaring them. This makes sure all the numbers are positive and that we pay extra attention to bigger misses. Average the squared misses. Next, we add up all the squared misses and find the average. This gives us a single number that tells us, generally, how big our misses are. Square root. Lastly, we take the square root of that average, which is kind of like undoing the squaring we did before, but in a smart way. This brings the number back closer to the original misses we measured. The final number we get is the RMSE. It's a way of saying, on average, this is how far my beanbag throws were from the target. A smaller RMSE means you were really good and consistent at hitting close to the target, while a bigger RMSE means there's room for improvement in your beanbag tossing game.
All right, so I get a general sense from that. Sounds like a statistical thing to me now, and not just a bunch of words. So show me some basic like example math problems that I might be asked to assess whether or not I actually understand this concept.
Sure, let's create some simple problems to help understand the concept of root mean squared error, RMSE. These examples will involve small sets of data to keep the math straightforward. Example 1. Measuring distance from target. Suppose you're playing a game where you need to throw balls at a target, and you record the distance from the target for each throw in meters.
Oh,
your distances
man.
are as follows. 1 meter, 2 meters, 1 meter, 3 meters, 2 meters. Problem. Calculate the RMSE to assess your accuracy. Example 2. Classroom quiz scores met in a classroom where students are scored on a quiz out of 10 points. The expected score is 10 points for each student, but 5 students scored 8, 9, 10, 10, and 7, respectively. Problem. Calculate the RMSE to determine how far, on average, the students' scores were from the perfect score. Example 3. Temperature predictions.
Yes, please break down step by step the first problem. Think out loud and show your work and double check your results. this is a kind of important concept. On my other channel, you'll see me juggling, and knowing the RMSE of my throws sounds like it would be pretty awesome. And reducing the RMSE would be pretty awesome.
Let's break down the steps to solve our example problem and calculate the root mean squared error, RMSE. Step 1. Calculate the differences, errors. First, we compare each of our beanbag throws, predictions, to where they were supposed to land, true values, to see how far off we were for each throw. For the first throw, we aimed for 5 but landed at 4, so the difference is 4 minus 5 equals minus 14 minus 5 equals minus 14 minus 5 equals minus 1. The second throw aimed for minus 2 and landed at minus 1, so the difference is minus 1 minus 2 equals 1 to 1, minus 2 equals 1 minus 1 minus 2 equals 1. Continuing this for all throws, we get the differences, minus 1, 1, minus 1, 1, minus 1, minus 1, 1, minus 1, 1, minus 1, minus 1, 1, minus 1, 1, minus 1. Step 2. Square the errors next. We square each of these differences.
Alright, it's a bit early in the morning for that. I'm watching that and I'm thinking I'm literally about to collapse and hit my head on something. So that would be great for, I think, a later video. I think Khan Academy probably has, so RMSE Khan, yeah, it probably has a whole lesson of things related to the root mean square error. We have a video here on it. We have another video here. So it's probably part of a whole free series on statistics and probability. I actually went through that series many years ago because I was just really interested in math, and I still kind of am. But it looks like Khan Academy might be down. I'm not sure what's happening with that. Let's just go to the main page of Khan Academy. That might be an older video or something. Yeah, so Khan Academy is up. Oh, and it looks like the other one. So yeah, that might be an older video that somehow was in the results but didn't. And this is what I should do, is donate to Khan Academy because I believe in it so much. But anyway, yeah, so we've got AP College Statistics, which is so cool. I think you can go and take AP exams, even as an adult. Anyone can go and take the exam at any time, and you get free, well, not free, you get college credits that would normally cost you hundreds, if not thousands of dollars for the price of the exam, which is not free, but it's a few hundred. So you can, for a small price, you can study all this on your own with your, in your pajamas and go and take the test. And in what took somebody a full semester for thousands of dollars, maybe in a few weeks, if you already kind of know this stuff, you can go and do it for like $100. So I urge anyone watching this, especially who's thinking about college, focus on these AP exams, because in my experience, college can be good for like forming a professional network, but going into college debt, which I don't know, like maybe it's not that bad, but I feel like the faster you get in and out, like the sooner you can start your career, and that's good. But you can see I actually have had some practice on this before, and we can see it is a comprehensive AP college course that you can get actual college credit from if you pass the exam. And this undoubtedly does include the RMSE, the root mean squared error. Problems about that I was talking to ChatGPT about, but realized that if I keep doing that, my head will bleed. Alright, so let's see here, which is probably funny to say because it's probably not that advanced of a subject. Alright, so moving on. RMS, we got the same values out there. So this is kind of interesting. The value is a little bit different. I don't know how that happened. Maybe the data was updated since the last time I ran this. We do have some linting differences, but that shouldn't matter. It's just a matter of preference in how you write the code, how the code looks when you read it back. It's really not something that's going to change the results. We did see a difference in this graph. It just turned out to look different. So it could have to do with where I'm running it from. They might be running it from a Mac. I might be running it, I'm not running it with like WASL, all complicated. So I'll just clear it and run again I feel like that's not the worst thing to do as a first instinct, especially if you're not doing anything expensive or super complicated. There are things you can do where you rent out processor time or like GPU time. And in that case, just constantly rerunning every cell is probably a bad thing. Or like a better example is like cloud networking. If you just constantly keep building new EC2 instances, that's not a good instinct. But we can see I ran it again and I got that different result. So I think that's probably valid. So I'm going to move on. Plot predicted height versus actual weight. Now let's plot the predicted height versus actual height to see how well this model performs at predictions. So there, if mine failed for whatever reason, this will probably show whether mine is more or less accurate than the example. Okay, so I'm not sure what this... Oh, I see. So you kind of have to be familiar with... and I did this same thing where I tried to create a new line by hitting Shift-Enter, but that's not how you create a new line. To create a new line, you just hit Enter. So you kind of have to know a little bit about Python syntax to put it on the right line. What is on each line is pretty clear from the example. So on the next line, they're going to have a blank space, and then after that, this AX. All right, and then after that, the Y equals Y is on the next line. All right, but the Y equals Y, I think, is on the next line simply due to a word wrapping. So I think this all can go on one line. Typically, it's not a good idea to put everything on one line or to put too much on one line because then you have to scroll back and it's hard to read at a glance. But I think in this case, it's fine. So yeah, let's run this cell again. There we go. And now we got that graph. This should look like the example. Oh, actually, we were missing a lot of code, so let's make sure that gets in there. I'm really glad I don't have to type all this code out. If I did, I probably wouldn't be doing these examples. All right. So that can be deleted. So we've got multiple ax.scatter statements. The first ax.scatter statement was here, and then we've got another one starting here. All right, and then the next one is looks like they got a blank line, and then pl.title. So notice this has no title here, so we're going to add a title, actual height versus predicted height. Then the next one is we're going to label the x-axis, which again, notice it's not labeled. And we're going to label the y-axis. All right, and then plt.legend, plt.show. See what's on the next page. All right, so now we should have this predicted here. So that's what was missing. This second one is yeah, predicted.size. So let's see what the graph looks like now. There. So now we've got predicted here. It looks about the same. So this is the predicted height versus actual height. This is a very simple yet powerful example of a realistic workflow for creating a machine learning model. So this would be great for my other, my personal channel, my hobby, which is juggling. Like the more narrow you can get the the error of your throws, the better you are, the more consistently accurate throws. I think I feel like there's a large component of being able to catch garbage, and I feel like the world's most accurate thrower is probably not as good as the second world's most accurate thrower who can catch any kind of garbage out there. So, but it'd be an interesting insight. So, let's move on to the next part. So the next part is the machine learning ecosystem. I'll advance my bookmark to 397 and delete the older one here. And they are listed in order here, so the furthest one down is the newest bookmark. Other than that, all I've got is notes. So this is a really good natural place to end the video, I think. So yeah, we got all the examples to work. Really pumped about that. That was I learned how to use Jupyter too. I kind of knew how to use it, but I got a good refresher. It always makes Python demonstrations and stuff look a bit more professional. So yeah, that's it for. I have a lot left in me. Usually I can do an hour, but I got to be mindful of the time. So thanks for watching, and see you in the next one.